Hello, welcome to Chemistry, the first in the video lecture series. Today's lecture is What is Chemistry? Topic 1, Video 1. The purpose of these video lectures are to allow you the opportunity to not only learn the material, but pause, rewind, rewatch, and occasionally relearn the material, even if you are unable to attend class and get the lectures that way. Today's lecture is What is Chemistry? It is an introductory lecture. It's an introductory lecture in that it allows you to get used to the format of the videos, as well as an actual introduction to the topic of chemistry. That being said, let's get started. Alright, it all began with alchemy. Chemistry for a really long time was known as alchemy. It wasn't necessarily a science, but more a system of viewing the world. In alchemy, it was much less scientific. Conclusions were not based on fact. As you can see from the chart, alchemy was based on some very basic and general, very unclear definitions of elements, if you will: fire, water, air, life, death. Something you might see or hear out of World of Warcraft, if it looks familiar to you. Some of the tenets of alchemy suggested that transmutation is possible. Transmutation is changing one substance into another, which is also capable in chemistry, but even to a greater extent, alchemy suggested things like lead, which is a very weak, poor metal, could be turned into gold. Alchemy also suggested the existence of a philosopher's stone, a mystical stone which, for some reason or another, could grant eternal life or heal all wounds, and in some belief systems raise the dead. Obviously, chemistry can do none of those things. The picture on the screen now is a image of what an alchemist's lab might look like. You see the imagery, the light, day, fire, and down here in the corner you see a chimera, a mixture of many animals. Those are obviously not capable in real life, at least not to that extent, and thus alchemy is no longer the mode of choice for scientists. Instead, during the 1500s, alchemy gave way because, well, let's face it, it was a lot of what it did was wrong, and it gave way to the practices of chemistry, which were much more scientific and much less mystical or religious, and it was based more on what you could actually see and compared to what these amazing things that alchemy predicted could happen. For the better part of 200 years, chemistry was an observational practice. We just mixed things together and saw what happened. After all, the difference between playing around and goofing off and science is writing it down. It wasn't until the 1700s that chemistry became what it is today, thanks to a man named Antoine Laurent Lavoisier, a French scientist who, rather than just observing, started to take very precise measurements. His work led to the change in chemistry from a very observable, very general science to a very exact mathematical science. As you can see on the screen, these are some of the relics from Lavoisier's lab. Very precise instrumentation scale over here to the right. This is a scale, and here he has some pressure vessels for measuring pressure and air volume. I think this is an air pump. I'm not 100% sure on that. But he was a very instrumented, very precise man, and because of that, chemistry became what it is today, a mathematical science. So what is chemistry, and why is it important? Why are we even studying chemistry? I mean, some of you are thinking to yourself, I'm not going to college. Why am I studying chemistry right now? And there are a lot of different answers for a lot of different people, and it really depends on what you plan on doing. Chemistry today, to start with, is a study of matter and how it interacts with each other. It's not all explosions and gunpowder and things boiling and the mad scientist and all of his fun stuff. Chemistry is actually a much more tame science than the movies make it out to be. And as Chemistry Cat says, do solids, liquids, and gas matter? And they do, because chemistry is all about matter. Matter is any substance or material that has a mass and a volume. Common forms of matter are solids, liquids, and gases. Those are the ones you deal with on an everyday basis. You know what solids are. You know what liquids are. You breathe in gases in and out every second of every day. So you're familiar with those forms of gases, and if you're not, then we need to do a little review. Some other types of matters that are less common and more scientific in today's fields are plasmas, which are highly energized, highly electrically charged masses that are very, very volatile. Plasmas can be found in stars, for example. And Bose-Einstein condensates, which are an extreme form of cold matter. Gases that have been supercooled to the point that they are liquids almost at absolute zero, and they have zero viscosity. Very interesting form of matter that we will discuss later in the year. But, like I say, more on that later. Some of the branches of chemistry, and this is where it starts to relate to what you would do with chemistry or why you're studying chemistry, are inorganic, which is primarily what we're going to do in this class. Organic, which is the study of living things and living matter, such as carbon-based compounds. Energetics, which is the study of how energy and matter interact with each other. Electrochemistry, how matter and electricity interact with each other. Thermodynamics, the behavior and movement of heat. Biochemistry, which relates back to organic chemistry, but it's a very specific science designed to study the chemistry of living organisms such as ourselves. Analytical chemists are very precise in their measurements, and they work for big companies such as DuPont and Kodak that use chemical substances on a regular basis and need exact chemical substances. Spectrometry is the science of figuring out what substances are based on their atomic structure. Nuclear chemistry is also a very prominent field today, in that it's where we're looking for energy supply, such as nuclear reactors and nuclear engines. And oxidation reduction chemistry is typically studied by specialists in the fields of explosives and ordnance disposal. With these fields of chemistry, there are different jobs and applications of the chemistry that you may not have been aware of. For example, some of you are probably looking at cosmetology. That is beautician school. Did you know that chemistry plays a really big part in beauty supply? Hair coloring is all chemistry, mixing the right amounts in the right ratio at the right temperature, leaving it in for the right amount of time. Ammonium thioglycolate, for those of you who have watched Clueless, that's the compound that gives you those luscious curls in perms. Pharmacy school is all chemistry, because that's what drugs and medicines are. They're chemical compounds. You also can use chemistry on your everyday basis, such as those individuals who are masons. That's all chemistry. Mixing the right types of materials to form the right kind of concrete in the right ratio. You've also got carpenters with their wood varnish. That's chemistry. Engines run on pure energy, which is chemistry. So a lot of ways you can use chemistry, even if you didn't think that it would apply to your life. So next time, measurement in chemistry. How do we measure? Why do we measure?